Okay, we have a short problem for today. After that extra long problem that we did last time, I thought it would be a good idea to back up and do an easier version that we'll be able to work up to the big one. Here it is. It says how many 5-digit pins with no repeated digits and that must either start with 7 or end with 8. So we'll let A, let's just say the set A for now, be 5-digit pins in the universe that start with 7. And may as well remind you that I want the same universe. U is equal to 5-digit pins, in this case, with no repeated digits. So I'll put that in parentheses. And let's let B be the pins that start with 8, or that end with 8. I want to do the calculation first, and at the end I'll show some examples of the allowed pins in this requirement. This is where in selecting a password, the program tells you what you have to have. It's kind of a funny requirement, but it's a 5-digit pin that has to either start with 7 or end with 8. So we look at all the ones that start with 7, and we look at all the ones that end with 8. And those turn out to be fairly easy. We did calculate similar things on that last big problem. The number of items in A, which would be the number of pins that start with 7, is going to be found by filling in 5 digits, and the first digit has to be a 7. Then we get to pick anything we want for the rest, but not repeating, so they can't be 7s, but anything we want is fine. So there's exactly 9 choices remaining for the second: 8, 7, and 6. So we get 9 times 8 times 7 times 6, which we did figure out last time was the equal to 3024. This happens to be a similar number of digits this time. It's exactly the same number of digits, so we'll have some of the numbers will be coming up again. And B, the number of items in B, it turns out again to be that same number, because now you have to put the number 8 as your last digit. Then since there are no repeated digits allowed, that means you get those same numbers of options for the other 4 digits. This one didn't say anything about whether you were not allowed to have certain digits as the first digit in your PIN number. So you can start with 0 this time, that'd be fine. So there are 9 options for the first digit there after you put 8 in at the end. So again, you don't have to even write it, it's 3024. Now here's the situation at this point. We are going to have to subtract the intersection of those two, but rather than just do it as if it's memorized, let's reason out why. So here's a picture of what we have so far. Okay, so this is my universe U. I think I can fit it on here. And let's see A and B. Here's A, here's B. So I've counted everything in A, and for an example, make that look more like an A. The items in A all start with 7 and are 5-digit pins, so this might have the number 7, 0, 1, 3, 2. That's a 5-digit pin number. And everything that's in B, those all end in 8. So we may have something that looks like 9, 1, 0, 7, 8. As long as it ends in 8 but doesn't have any repeated digits. And then now you can see what goes in the middle there are going to be pin numbers that both start with a 7 and end with an 8. And those are fine. The question says they must either start with 7 or end with 8, but that means that they could have both. So this one would be, for instance, 7, 1, 9, 2, 8. All those are valid. Now, if we've counted everything that's in the circle A to come out to 3,024 possible numbers, and everything that's in the circle B, there's another 3,024, then what we've done is we've counted this one in the middle twice, and any other pin number that landed in the middle, the intersection, has been counted twice. So we need to subtract that off, and so we also need to know how many are in there. So that's this. Fill in the blanks again. This time, however, there's a 7 at the first blank and an 8 at the end blank, only leaving 3 blanks to choose. And there's only 8 numbers to pick from for the first, and then since there's no repetition, 7 and 6. We worked that out last time. That comes out to 336. So, final answer is going to be, I think I can erase the question up here. Let's see, I have a nice picture of it. And the final answer, I'll also put in the PDF. That will be, if I want to count everything that's in both circles, that was the OR, then I'll need everything in A, everything in B, and subtract everything in the middle. So I'll need 3,024 plus 3,024 minus 336, and that comes out to 5,712. So notice, comparing this to the longer problem that we did first, this found is just a piece of it. In the longer problem, there were 2 extra things involved. One was that there was a whole other group C. It was the group that had the third digit equaling 2, I believe. Yeah. Then another difference from the previous problem is that in the previous problem we made those particular pin numbers illegal. So instead of counting what was inside the circles, we wanted to count what was in their complement outside of all the circles. So we had to first find out what was inside the circles and then subtract that from the total universe of 5-digit, non-repeating digit pin numbers.